flashlight consists of a reflector cap, a light bulb, batteries, and a barrel-shaped housing with a switch. There are several ways to connect the battery and bulb from a flashlight so the bulb lights up. The important thing is there has to be a complete path or circuit that includes the bulb filament, runs from the positive terminal at the top of the battery, and runs to the negative terminal at the bottom of the battery. Electrons flow from the negative part of the battery through the wire, to the side of the bulb, through the filament inside the bulb, out the bottom, and through the wire to the positive part of the battery. The current then passes through the battery to complete the circuit. When the switch is turned on, the electrons in the wires and the filament begin to drift through the circuit. Electrons don't pile up inside a bulb, but instead flow through its filament. Any path that electrons can flow along is a circuit. A gap is usually provided by an electric switch that can be opened or closed to either cut off or allow electron flow. A break in an electric circuit results in a complete stop in the flow. Opening a switch stops the flow of electricity. An electric circuit must be closed for electricity to flow. Most circuits have more than one device that receives electrical energy. These devices are commonly connected in a circuit in one of two ways: series or parallel. If three bulbs are connected in series with a battery, they form a series circuit. Charge flows through each, one after the other. When the switch is closed, a current exists almost immediately in all three bulbs. The current doesn't pile up in any bulb, but flows through each bulb. Electrons in all part of the circuit begin to move at once. Eventually, the electrons move all the way around the circuit. A break anywhere in the path results in an open circuit and the flow of electrons ceases. Burning out one of the bulb filaments or simply opening the switch could cause such a break. In this simple series circuit, a 9-volt battery provides 3 volts across each bulb. For series connections, electric current has a single pathway through the circuit. The total resistance to current in the circuit is the sum of the individual resistances along the circuit path. The current is equal to the voltage supplied by the source divided by the total resistance of the circuit. This is Ohm's law. The voltage drop, or voltage difference across each device, depends directly on its resistance. The sum of the voltage drops across the individual devices is equal to the total voltage supplied by the source. The main disadvantage of a series circuit is that when one device fails, the current in the whole circuit stops. Some cheap light strings are connected in series. When one bulb burns out, you have to replace it or no lights work. That's it for this time. Join me next time when we look at parallel circuits.